Hello, everyone. This is a recorded lecture for PHCH 3313 Health Data and Statistics course. What we'll be doing in this video is looking at comparing two sample means, and we will look at an example of how to use a t-test in R and also create a box plot in R. So previously in course and in these slides that I'm presenting now, we have already looked at how to do by hand a one sample mean for comparing it to some hypothesized value. So we also went over the two sample means in class, and so I'm not going to go over these slides in the same detail I did in class, but we'll go over just the concept of what we're doing here with comparing two sample means. Okay, so if we're conducting a hypothesis test for two sample means, if we're looking at means, then we're interested in continuous outcome. So remember, some examples of continuous outcomes would be BMI, cholesterol, blood pressure, weight. These are all examples that we've looked at through this course of a continuous outcome. But now what makes this the two sample means is that we're looking at two independent groups. That's two samples. So then we have, examples of two groups. We could have either disease group and a non-disease group. We could have a group that answered yes to something or no, or we could also have a treatment group or an intervention group. And then what we want to do then is compare the mean of that continuous outcome in group one to the mean in group two. So an example that we could use is if our groups were men and women, we could have a null hypothesis that says, is the mean weight in men equal to the mean weight in women? So then on the other hand, we'd have the alternative hypothesis, which could be, is the mean weight in men different than the mean weight in women? Okay, so this is the form that the hypothesis takes for two sample means. So we have a null hypothesis, H0, where mu1 is equal to mu2. So here, mu1 is equal to the population mean in group 1, and mu2 is equal to the population mean in group 2. And now we have an alternative hypothesis that we have to specify, H1, and we have three ways of doing this. The first way is a one-tailed test where we could hypothesize that the population mean in group 1 is greater than the population mean in group 2, indicated by the greater than symbol. The next test that we could look at is also a one-tailed test, but this time we could look at if the population mean in group 1 is less than the population mean in group 2. So that would be indicated by the less than sign. But then really, the test that we're going to focus on more heavily is the two-tailed test, which indicates that the population mean in group 1 is not equal to the population mean in group 2. So the advantage of this method is that it captures both of the other one-tailed tests, both the scenario where either group 1 is less than group 2 or group 1 is greater than group 2. So we'll really focus on the two-tailed test to see if there's any difference at all between the two population means. So this figure gives an idea of kind of the framework that we use. So we have our full sample of data that we've collected, and then we have some way of breaking our participants into group 1 and group 2. And this is normally done by some defining characteristic. So previously we looked at examples of men and women if we were dichotomizing that. So then group 1 could be men, group 2 could be women. And then, so we have this information that we've gathered. Well, then for group 1, we could summarize the sample size for group 1. We could also calculate the mean outcome in group 1, indicated by X bar subscript 1. And we could also calculate the standard deviation of the outcome in group 1, indicated by S sub 1. Well, that's great. We've done it for the group number 1. Now let's do it for group number 2. We could do the same thing. We could also summarize the sample size, the mean outcome, and the standard deviation for group 2. So then there are two main test statistics that are used for two sample mean hypothesis test. And so I've broken them into 2 here, kind of giving you the layout for when you would choose one test or the other. Now, you'll notice in the left-hand column of this table that there's quite a few conditions that need to be met to use a z-test. So both groups have to be larger, have subgroup sample sizes greater than or equal to 30, and we also have to know the population standard deviation. Now, most of the time in practice, we don't know the population standard deviation, so it's not likely that we can use the z-test. So in this class, we're going to focus on the right-hand column here, which is the t-test. So this is whenever we have either one of the subgroups, sample size subgroups is less than 30 for either group 1 or group 2, or the population standard deviation is unknown. And most of the time, the population standard deviation is unknown, so we will default to the t-test. So because this is from 2 samples and we use a t-test as the test statistic, this hypothesis test has a very specific name and it's called a 2-sample t-test. This is probably one of the most widely used statistical tests that you will encounter in the literature, because a lot of times we have a continuous outcome that we want to compare between 2 groups. All right, so for the 1-sample mean, when we compared that to a hypothesized value, we looked at how to calculate that by hand, and you will be expected to know how to calculate that by hand. However, when we do the 2-sample mean, it's not impossible to do these by hand, and it just takes practice, but we're actually going to let R help us, and R is going to help us choose the test statistic. It's going to help us construct our decision rule, and it's also going to help us calculate the test statistic for the 2-sample means. So we're going to really rely on R to conduct a hypothesis test for 2-sample means. Okay, so these are the 5 steps that we've been using for hypothesis testing. And so, the 2-sample means hypothesis test or the 2-sample t-test, we're going to follow the same 5 steps. However, up till now, we really focused on 5.1 as the way to determine if we reject the null hypothesis or if we fail to reject the null hypothesis, because we compared a t-test to a critical value. Well, now we're going to learn how to use a p-value to compare that to the significance level of alpha to help us make a decision on if we reject the null hypothesis or not. Okay, so this is how this is going to go. We're going to analyze our sample. We're going to use R to give us a p-value. And that p-value, we're going to look to see whether or not is less than 0.05 or if it's greater than or equal to 0.05. Now, the 0.05 is coming from our alpha level. Remember, for this class, we said that we were going to always use a significance level of 0.05 or 5%. So that's the probability that we're willing to make an error, a type 1 error. Okay, so if the p-value is less than 0.05, we're going to reject that null hypothesis, and we're going to favor the alternative hypothesis. So then what that means is that there's a significant change or difference or association between the 2 means. So for this test, it's looking at a difference between the means. So that would indicate that there is a significant difference between the means between the 2 groups. Okay, however, what happens if we have a p-value that's greater than or equal to 0.05? Well, then we would say that we fail to reject the null hypothesis. This means that we are favoring our null hypothesis. We never say that we accept the null hypothesis or conclude that the null hypothesis is true. We just say that we favor the null hypothesis because we don't have enough information to reject it. So a little bit of wordplay, some double negatives running on there, but just remember that we fail to reject the null hypothesis, we favor the null. This indicates that there's not a significant change or a significant difference or association. So for this 2-sample t-test, we'll say that there is not a significant difference between the means of the 2 groups. Okay, so we looked at this in class last period, but these are the conclusions and summarizing the significance for a hypothesis test of 2-sample means. So if we reject the null hypothesis, that is, we favor the alternative, we would say that we reject the null hypothesis and favor the alternative hypothesis. And we have enough evidence at alpha equals 0.05 to show that the mean blank is greater than, less than, or not equal to group 1 as compared to group 2. So here I've given you a template of a good way to write these results. Where it says variable, that's where you would replace your continuous outcome. So if we were comparing BMI between two groups, you would say that the mean BMI is, and then you need to choose whether it's greater than, less than, or not equal to. And you choose this based off of the type of hypothesis test that we're looking at, if it's one tail or two tail. Now, we've said that in this class, we're going to mostly focus on that two-tail test. So most of the time, you're going to choose the not equal to as your option. So then to kind of sum that up, we would say that we have enough evidence at alpha equals 0.05 to show that the mean BMI is not equal in group 1 as compared to group 2. Okay, so that's if we reject the null hypothesis. If we fail to reject the null hypothesis, we would state that we do not have enough evidence to reject the null hypothesis, and we favor the null hypothesis. That is, we do not have enough evidence at alpha equals 0.05 to show that the mean BMI is not equal in group 1 as compared to group 2. So those are a couple of templates for you to use whenever you're getting to making the conclusions and summarizing significance. Okay, so let's look at an example using the NHANES data. So remember that the NHANES data is actually the data that you're going to be using for your final project. And what I've done is I've created my own example data using diabetes as a health outcome. But this hasn't been assigned to any of the other groups. So diabetes is what we'll use as an example. So if one group isn't getting an unfair advantage here of me showing how to do their health outcome. Okay, so using the 2017-2018 NHANES data, we'll perform a two-sample t-test to compare mean hours of sleep between those with diabetes as compared to those without diabetes. So this data set contains information from individuals who participated in the National Health and Nutrition Examination Survey, known as NHANES. We're going to use two variables from that data set. We're going to use sleep, or hours sleep, I think it's called in the data set, which is the number of hours usually slept on weekdays or work days. So this is reported as a continuous outcome, and participants were asked, how many hours did you usually sleep on weekdays or work days? And then for this example, we're going to use DM, or the diabetes variable. And this is whether or not the participant has ever been told if they have diabetes. So they could either answer yes, they've been told they have diabetes, or no, they haven't. They have not been told they have diabetes. Okay, so this is the R code that we're going to use to do the two-sample t-test. As you can see, it's pretty simple. There's only 2 lines. We first have to read in our data, which I've given you these data sets, and then we have to use the t-test code. Now, I want to point out that what I've highlighted in yellow is, or change the font color to yellow, this is what you're going to need to change for your final project. So I'm working with NHANES DM, the diabetes data, but you're going to be working with NHANES and your health condition. So you'll need to change this part of the code to reflect the file name that I've given you for your data. And then in the t-test, you're going to have hours sleep. That's going to be the same for your project. But then diabetes variable is what you're going to change. So my health outcome for this example is diabetes, but yours could be coronary heart disease. It could be oral health. It could be gout, whatever was assigned to your group. So you'll need to change that in your R code as well. Okay, well, let's switch over to R and look at this example of how we would actually run this. So the first thing that we need to do is import our data into R. Well, I guess actually the very first thing that we need to do is start a new R script in R. Now, remember, you can copy and paste this link into your web browser, and this will automatically open up a Google Colab script that's running in R. And I've made a YouTube video about this previously of how to get this going. So if you're having issues or you've just forgot because it's been a while, this is how you're going to open up a new Google script in R script in Google Collaboratory. Once you do this, the most important thing is that you're going to need to check your runtime. So go to the runtime up on the top menu bar, scroll down to change runtime type. And when you open this under notebook settings, you should see that R is running here. If this isn't indicated here, then your code is trying to run Python. So the best solution that I would recommend is that if you get that and it's not in R, just copy and paste this into your web browser and start a new document in R. Okay, so we have our R script now. We want to read in our data. Now, I've also made a separate video for how to import your data and do some summary statistics based off of your data. So if you want further explanation of how to do that, please refer to that video. But remember, the first thing that we're going to need to do is go to the left-hand file and click on this left-hand side and click on this folder. Now it's connecting to runtime, so you might see this message connecting. So we'll give it a minute to connect and initiate. Okay, so now that it's connected and initialized, we can open up that folder again on the left-hand side. Now, notice there is no CSV file in this folder. So what we need to do is we need to upload this data set to where it shows up here in this file, because then we'll be able to import that into R. So the way that we do that is if we go up here to this page with the up arrow on it, we're going to click on that, and it's going to open up a folder on your phone, on your computer. Now, I don't know where this is going to automatically send your file location to, but you need to search to the place that you have this data saved on your computer so that you can upload it. So I'm working with the diabetes data. I'm going to select NHANES_DM and click open. And that's going to give me this warning. Now, this warning, I'm going to repeat it again, even though it's in the other import video, is very important. So it says, ensure that your files are saved elsewhere. This runtime's files will be deleted when this runtime session is terminated. What that means is if you close your browser that you're working on this code in, it's going to delete that data. So if you come back, if you close this browser and then come back to work on this project later, you're going to need to re-upload your data. Okay, so now I have my folder over here on the left-hand side. So now R can import that. So we can go ahead and close that. We don't need that anymore. And now we can run this, and it should import our data for us. Okay, so we ran, and there's this green little check mark, but I didn't ask it to actually put anything out to the console, so that's why I didn't get anything below here. But what I've done is I've imported the CSV file using this read CSV function. I've imported this data set, which I'm going to be working on for this example, and I've saved it as data called sample.data. Now, what I've also done is I've used this function called attach on my sample data. What this has done is this has created a variable for every single column in my CSV file. Without getting too complicated, this is just going to help us simplify our code to make it easier to find our variables. Okay, so now that we have this in here, we might just want to check to make sure what the dimensions of our data are. So check dimensions of data. And we're going to use using the dim function. So we're going to do dim of sample.data, and then we can run that again, and it'll tell us that the This first number is the number of participants we have, and the second number is the number of columns that we have. So that looks good because I've looked at my CSV file before starting this, and I had 30 participants and I had 5 variables. Okay, well, now that we have our data imported, we're ready to go ahead and conduct a 2-sample t-test. So I'm going to copy and paste the code in. So this is how we conduct a 2-sample t-test. We're going to use the t-test function to compare the mean hours of sleep between those with and without diabetes. So remember, in this t-test code, what you're going to need to change is just this word diabetes. So you're going to need to type in your variable name for your health condition. And make sure that you have the correct caps, because this is looking at lowercase and uppercase. It is case sensitive. So make sure that if it's capitalized in your data set, it's capitalized in this data set or in this code. Okay, so we have this set up where we have hours of sleep, tilde, diabetes, and then this data set here, this is just pointing the t-test function, where to look for the data. So that's what we've done there. Once we have that, we can go ahead to the left-hand side and hit run, the little play button, and we're going to get this output here. Now, what I've done is I've actually put this back into the PowerPoint slides and highlighted how we go about making decisions based off of this output, because it can look kind of messy from here. But this is how you would run a t-test, a 2-sample t-test in R. Okay, so let's go back to the slides that we have. So now this is the output that we just got from R. So let's go through this and show how we would actually make some conclusions. Well, the first thing is we said that we were going to compare our p-value to our significance level. So remember that our significance level is 0.05. So we're going to compare the p-value to that. Now, the p-value is indicated here. It's highlighted in this red box. It is 0.7412. Now, 0.7412 is greater than 0.05. So based on that chart that we looked at before, this means that we're going to fail to reject the null hypothesis. So the way that we would write this conclusion is that we fail to reject the null hypothesis, and then make sure you tell me why, aka that the p-value was greater than 0.05, and that we favor the null hypothesis. That is, we don't have enough evidence at alpha equals 0.05 to show that the mean hours of sleep differed for those with diabetes as compared to those without diabetes. So the main takeaway here is that we compared the mean hours of sleep between those with diabetes and those without diabetes, and there was no statistically significant difference between those two groups. Okay, some other things that you can use this t-test output for is you could look at the mean hours in each group. So it actually summarizes the mean in the no group, that is those without diabetes, and the mean in the yes group, those with diabetes. So then you could also summarize by saying that the mean hours of sleep among those with diabetes was 6.9 hours, and the mean hours of sleep among those without diabetes was 6.4 hours. And actually, this is one question that you are asked on your final project to do. So you can use the t-test to help you report these means. All right, there's one more important part that we're given here, and this actually is connecting us back to whenever we did confidence intervals. So here, the t-test gives us a confidence interval in the output. So then we just need to make sure we know what this confidence interval is looking at. So here, it tells us that the alternative hypothesis is the true difference in mean between group no, and group yes is not equal to 0. Or another way of saying that they're not equal to each other. So then this 95% confidence interval is looking at the true mean difference in hours slept. So then what we could conclude here is that we are 95% confident that the true difference in mean hours of sleep between those with and without diabetes is somewhere between negative 2.2 and positive 3.0 hours. So that's what this confidence interval is telling us. If you need any clarity for confidence intervals, you might go back and review the slides of chapter 6b, confidence intervals, where we looked at the difference in two means, and that may help you with where this is coming from. Okay, so next what we want to do is we've made our conclusions about hypothesis tests. That's great, but I think it's also important to visually display the data as well. So what we want to do is we want to use that NHANES data set that we were just working with to create a box plot figure that has two box plots on it to compare the mean hours of sleep between those with diabetes as compared to those who don't. So this is the code that we're going to use to do this. Again, I've highlighted in yellow what you need to change for your final project. So I'm working with NHANES DM data because I'm working with diabetes as an example. But you will be working with a different data set. So you need to change this data set name to make sure it corresponds to your group's data. In the box plot statement, you'll also want to change the word diabetes. This needs to match the variable name for your health condition. And then there's one more thing that you need to change down here in this line where we create the means. So don't change the sample.data $, but change this word diabetes to match your variable name. And then you don't need to change anything in this points line. Okay, so actually let's do that in R before we look at these results too much. Okay, so we'll create a new block of code down here. We've already imported our data, so we don't need to do that again, but we will, I will copy paste this code in here. So now what we're going to do is create a box plot to compare the distribution of hours of sleep in those with the health condition, aka diabetes, as compared to those without the health condition, so those without diabetes. So this code actually looks extremely similar to our t-test, except for now we have the box plot function that we're going to use. So you can see the convenience of using R is that it has a lot of these things already built into it for us. So we're going to use boxplot. We do hours of sleep. That's going to stay the same for your final project. Then we have the tilde and then the health condition of interest. So this health condition of interest is going to depend on what group you're in. And then this data equals sample.data. This is just pointing R where to pull the data from. This means line, what we're going to do is we're going to actually plot the means onto our box plot. Because if you remember from our summarizing data section, the box plot normally only presents the median, but we want to present the means. So this line helps us do that. And then lastly, this points function is what's going to add dots onto each of our box plots. But that might be a little clearer after we run the data or the code. Okay, so this is the outcome that we get, the output that we get from R when we create our box plot. So you should have something that looks like this. And I'm going to go ahead and pull the slides back up because I have a summary on those two slides. So this is the output from R. So here, notice on the y-axis, we have our hours of sleep. And so then this should be probably within the range of 2 to 14, I think was one of the maximum values that the survey allowed. So it should be between 2 to 14. If you have something else here on the y-axis, like 300 to 3,000, something off, that's an indicator that you probably graphed the wrong variable. So make sure that this says hours of sleep and is somewhere from 0 to all the way up to 14. Now, on the x-axis, we have the diabetes groups. So then here, diabetes, those who indicated that, yes, they had been told they have diabetes, those are all summarized in this box plot on the right. And then those that don't have diabetes are summarized here on the left. So then what we want to do is compare the means using these box plots but also just having the distribution helps us see the min and max values, the interquartile range, and the median between the two groups. Okay, so some things to point out about these box plots and some things you might summarize in your final report is that the dots here represent the mean hours slept. So the dark bars, though, represent the median. So whenever we're using a two-sample t-test, that hypothesis test we said is comparing the means between two groups. So if we're using the two-sample t-test, we want to compare the means, which is why we added these points onto the graph, because otherwise we haven't plotted the means at all. We've only plotted the medians. Another point that I want to make about this is that notice how these 2 points are roughly horizontal to each other. So the mean hours slept in each group, the dots, are at about the same height. So this indicates that their means are very close to each other. So this is just another indication that the mean hours slept is not different between the two groups. And that's similar to what we found in results before, where we saw that the mean hours in one group is 6.9 hours, and the mean hours of sleep in the other group was 6.4. So this concludes my example summary of comparing two sample means. We looked at the background for the two sample t-test, how to run the t-test in R, and we also looked at how to create a box plot in R, and we looked at how to interpret the results for both the t-test and for the box plot. Please let me know if you have any questions about these concepts.